The universe should be empty. Just think about that for a second. The very fact that you and I are here, it's actually one of the most profound anomalies in all of science. Welcome to case number 07 of the GEM files. Today we're opening the vault of broken physics to dive deep into an incredible explainer on the matter-antimatter mystery. We're going to investigate exactly why the cosmos didn't just completely destroy itself. To really grasp the scale of this, we've got to look right back to the beginning. The simplest symmetry models of the Big Bang tell us that the birth of the universe should have produced matter and antimatter in exact equal amounts. Literally a 1-to-1 ratio, a flawless mathematical mirror. But, there's a pretty catastrophic problem with a perfect mirror. When matter meets antimatter, they both annihilate completely into pure energy. So if that early balance had been exact, the predicted status for our early universe was total annihilation.
Imagine a razor-thin, elegant geometry representing the matter that makes up everything around us. Beside it, its perfect counterpart, antimatter. Beautiful, balanced, and identical in almost every way except they're mirrored. Now, if this cosmic balance had held up, these two would have completely canceled each other out in a brilliant flash. We wouldn't have stars, no planets, absolutely no complex chemistry, and definitely no us.
According to the simplest symmetry picture, reality should have erased itself before it ever became a world. It's wild to consider the heavy implications of that, an aborted reality, a cosmos that simply sparked and then faded right back into an empty void.
But obviously, when we look out across the cosmos, we don't see an empty void, do we? We see sprawling galaxies, we see stars, planets, complex chemistry, life. Almost everything we can touch, see, and measure is made out of matter. Meanwhile, primordial antimatter is practically missing. We really only see it in tiny, brief sparks during massive high-energy events. The perfect cancellation just failed. The universe did not cancel. Something survived.
So let's open our evidence log for case 7. We're going to cover 1. Total annihilation. 2. The residual. 3. The vault opens. 4. The broken mirror. 5. Coherence geometry. And 6. The surviving reality. Section 1. The vault opens. Opening this vault of broken physics isn't about rejecting modern science. Not at all. Think of it as a highly prestigious forensic look at the boundary lines of human knowledge. Modern physics is not broken, but it has stress fractures. The standard models we use in particle physics are incredibly powerful, right? But when they face a foundational anomaly like this, the actual survival of matter, they still come up incomplete.
Section 2. Search for broken mirrors. Now, physicists haven't just ignored this massive impossibility. For decades, they've been conducting this rigorous search for tiny flaws in the cosmic mirror, a process known as baryogenesis. Looking at the standard avenues of investigation, we see things like particle decay asymmetry, the Sakharov conditions, mechanisms of baryogenesis, and perhaps the most critical standard clue of all, CP violation.
So what is CP violation? Well, it's a confirmed, completely observed physical phenomenon. It basically proves that charge and parity symmetries don't hold up perfectly. In some very specific particle decays, matter and antimatter actually don't behave as perfect mirror opposites. The standard model definitively proves that the mirror is in fact cracked. The asymmetry is completely real. But here's the crucial catch. The problem is not that the mirror has no cracks. The problem is that the cracks we know are not large enough. The amount of CP violation we can account for right now in the known standard model is mathematically insufficient to explain the overwhelming massive dominance of matter in the universe we live in. We are absolutely missing a piece of the puzzle.
Section 3. Geometric persistence bias.
To find this missing piece, let's bring in a fascinating interpretive reframe from the General Emergence Mechanics, or GEM, conceptual framework. Instead of strictly looking at particles bumping into each other, GEM shifts our focus to the underlying coherence geometry. The core of this is persistence bias. In this model, a structure survives not because it won some violent physical war of force, but simply because its specific geometric configuration is quite literally cheaper to hold under the universe's global coherence budget, kind of like taking the path of least resistance.
Let's put this into a broader timeline. The early universe wasn't some calm, quiet place. It was an extreme, completely out of equilibrium environment. Think of it as a brutal phase filter of harsh expansion and rapid cooling. The universe was crossing violent phase boundaries left and right. And during these intense transitions, any possible configuration of reality, whether that was matter or antimatter, had to pay strict curvature and persistence costs just to keep existing.
This completely reframes how we view antimatter. It's not some kind of evil matter or mystical negative energy. In GEM, it's simply a reverse coherence geometry. If matter and antimatter were perfectly symmetric in how admissible they would have canceled completely. But inside this extreme phase filter, antimatter didn't lose a cosmic war. It merely failed the global persistence filter. Its reverse geometry canceled out locally, leaving matter behind as this highly stable residual.
Section 4. What broke the mirror? So how did a slight geometric bias prevent the absolute cancellation of the cosmos? Well, we find these connections scattered throughout the wider GEM vault files. To really understand persistence bias, we have to link it back to early universe phase transitions, the inherent handedness or chirality of nature, Z3 and Z2 geometric symmetries, and depth monotone evolution. The survival of matter is deeply, inextricably tied to those extreme out-of-equilibrium conditions that govern the universe just mere fractions of a second after its birth.
The implications of this are just staggering when you really think about it. All the stars you see in the night sky, the planet you're standing on right now, the very chemical structures that make up your body, they are all just the surviving residual of a tiny geometric bias. Reality is what remained after symmetry failed to cancel itself. The early universe just couldn't afford to keep everything, and in the end, it was matter's geometry that proved just slightly cheaper to hold.
The vault of broken physics isn't asking for your blind belief. It's asking us to look incredibly closely at what actually breaks the mirror. This whole mystery acts like a warning light on the dashboard of modern science, pushing us to look deeper into the very architecture of existence. So I want to leave you with this final, lingering thought to ponder today. Did matter actually defeat antimatter in the early universe? Or did one geometry simply survive its mirror?